What is oogenesis? Children, oogenesis, as we've discussed, is the formation of ova. From where is this ova being formed? Very good. These ova are being formed from the germinal epithelium cells that form the outer layer of the ovaries. Right? Now, we must remember that the first stages of development occurs before birth, where in the ovaries of the female fetus. So the number of ova now in each of the ovaries of a female is determined at birth. What happens is that all the ova now that have been formed, they will remain dormant or they will be resting until the female reaches puberty. Right? And then what happens? Then oogenesis will begin in the fetus, and it will continue through puberty, and it will end when the female reaches menopause. And what is menopause? Well, when she's about 50 years of age, right? That's when we say the woman reaches menopause. Okay? It's where her menstruation is going to stop. And this will also indicate the end of her fertility. She is not fertile anymore. She cannot have children anymore. It marks the end of the female's reproductive years. Once the female reaches menopause, then what happens is that her LH and her FSH levels, meaning her luteinizing hormone and her follicle stimulating hormone, those hormone levels will remain high. But her estrogen and progesterone levels will remain low. She can no longer ovulate and she can no longer conceive a child. Let's move on to the process of oogenesis. Right. Now, as we describe the stages in oogenesis, we are going to highlight what happens before birth and then what happens at puberty. Let's begin. Now, children, did you remember the germinal epithelial cells we were talking about? Those cells that were forming the outer layer of the fetal ovary? Now, those cells, children, those germinal epithelial cells are all diploid, okay? Now, what's going to happen with those diploid germinal epithelial cells? They are going to divide by mitosis. And when those germinal epithelial cells divide by mitosis, they are going to give rise to diploid oogonia. Now, here you will see oogonium, that is just a singular. Oogonia is the plural. Right? So what happened? The germinal epithelial cells that were busy forming the outer layer of the fetal's ovary, those cells started to divide by mitosis, giving rise to diploid oogonia. These diploid oogonia, children, are going to start growing. Right? And when they start growing, they are going to develop into diploid primary oocytes. Now, these diploid primary oocytes, they are going to remain dormant, right? Inactive. They are going to be resting from birth until puberty. Now, let's talk about what happens at puberty. At puberty now, these primary oocytes, right, who are all diploid, they are going to undergo meiosis 1. And after they undergo meiosis 1, each of these primary oocytes will give rise to larger haploid secondary oocytes, right, as well as a smaller first polar body. Now remember, the secondary oocyte and the first polar body that have been formed are all haploid. Why? They have undergone meiosis 1. And we know that meiosis is a reduction division. It changes diploid cells into haploid. this secondary oocyte, children, will be released from the ovary in a process called ovulation. Now remember that this meiosis 2, the second meiotic division, will only occur if a sperm fertilizes the secondary oocyte. Okay? If a sperm fertilizes a secondary oocyte, then we move on to meiosis 2. So what happens then after meiosis 2? After meiosis 2, this secondary haploid oocyte is going to divide into two daughter cells. And what would be the two daughter cells? Two daughter cells will be a large mature ovum that's still haploid, as well as another polar body. Now sometimes this first polar body, children, also divides to form its own two polar bodies. Oogenesis produces 4 haploid cells, right? And what do they consist of? They consist of 3 polar bodies that will degenerate or break away and break down and fall away, as well as 1 haploid ovum.